Okay, so can everyone see my screen? Okay, awesome. So I'm just going to, let's go to a slideshow. All right. So today we're going to be talking about REST APIs. So what are these? That's the topic of the lecture. So before we actually get into REST APIs, let's first talk about clients and servers. So we talked about this, I remember a while ago, probably in the first week of the course, we did very briefly mention the, the idea of, clients and servers, but let's go more into it. So the client server model is kind of forms the basis of how devices and applications communicate and share information. So it's quite common. It's a very important concept. And so in this model, we have clients, which these are usually devices, kind of like your smartphone, your tablet, your laptop, even your fridge could be a client, and or applications. So your web browser and your mobile app, those are also can be thought of as clients. And servers are powerful computers and systems that store and manage data, services, or resources. And so we can almost think of this like a division of labor. So clients will make requests for things that they need to the server, and then the servers fulfill those requests by providing the required services and data. So let's go over a few examples. Trying to log into YouTube. So when you log into a platform like YouTube, we can think of the device that we're on as the client. And we're requesting access to account information, playlists, and videos from YouTube servers. So YouTube, that's the server. And based on what information we give it, right, they will send a response. So if the login's successful, then they'll send back all that information, and now suddenly we have access to our account. Trying to watch a video on YouTube is pretty similar. So your device, the client, requests access to a video's data from the YouTube servers. And of course, YouTube servers, they will, if that video is found, if everything's okay, they'll send that back. There's also, we're going to talk a lot about a restaurant throughout this lecture, and we're going to be using the restaurant as an analogy to discuss REST APIs. But in a restaurant, so you can think of yourself as the client. You're sitting down at a table and requesting a meal from the waiter. And so the waiter returns with food. So you can think of the waiter as the server. Does anyone have, maybe in the chat, some other examples of, I guess we can think of client server model? Yeah, feel free to share it in the chat. Or unmute yourself, or you can also unmute yourself and share an example as well. Online bookings, for sure. Absolutely, yeah. It's the same for Facebook and Instagram. So if we're trying to log into their servers, trying to log into Facebook, it's very similar. We send a login request and we give it some information, like probably our username or password, stuff like that. And then on their end, if it's successful, if it's like correct, then they'll send back a response with all the information. Exactly. So these are all some really good examples. Online banking services, absolutely. Online transactions. Um, Yes. And I actually think with the online transaction that we would probably send the request to the like the actual, like let's say if you're trying to do an RBC, like an e-transfer, um I believe the request you'd actually send it to the RBC server and they manage everything and then they send the response back. So yeah. Okay, awesome. So so with that talked about, now let's get into APIs. And so we can think of the API as an interface, traditionally between software and a developer that permits interaction. And naturally, there are rules and protocols that need to be followed so this interaction can take place. And I'll actually be going into an example in detail on the next slide, just to make this more clear. So we're going to be going into an example of a restaurant, just to cover that idea. And so one thing I will mention though is that there is something called like separation of concerns. So the developer only needs to know how to interact using how to use the API to interact with the software. They don't need to know how the internal workings of that software. Nor does the software need to know everything about the developer. So in that way, that is the idea. Like the API is sort of that interface that lets these two ends communicate. All right, so let us go to the next slide. So we're going to talk about a restaurant. The restaurant's going to be our example. So I'm going to introduce the analogy of a restaurant that will make this more straightforward. And in this analogy, we're going to think of the restaurant as the software application and the customer as a developer. So you might be thinking, what's the API? So in this analogy, the API is going to be the restaurant's menu. It's a structured list of options that the developer can choose from, and basically how the developer will interact with the kitchen. It's going to be through that menu. Now, of course, you know, the waiter's involved, but we're just going to think about it in that way. Because just like customers don't really need to understand how the kitchen works, developers don't need to know the software's internal workings. Now, the customers they don't need to know how the kitchen works, but they can still get their meal if they have the menu and they know how to use the menu. Then, you know, in the same way, the developer can also just get exactly what they want from that software using the API. They don't need to know how the software goes about figuring out that data that they want. All right, so does anyone have any questions so far? Or is everything's clear? Okay, awesome. All right, I'm just going to need 1 or 2 minutes. There's something I need to check for this is so I'll just be back in like 1 minute. This is for a later part of our lecture. I just need to see if it is working. All right, sorry about that. So just to clarify, is this idea clear of like the API in this restaurant analogy where it's going to be the menu and yeah, like the customer in the restaurant is the developer. The restaurant itself or the kitchen that is sort of making things for them, that is the software. And the menu is the API. It lets these it lets them communicate. All right, so let's continue to the next bit. So, right, so again, developers rely on the API to convey their requests to software. So now let's get into, this is just the sort of a photo of the example as well, kind of showing here. So this example is a bit different. So we talked about in this case, here in this analogy, the API is actually the waiter. Actually, this is a pretty good analogy. And then, yeah, we can think about the back end as a chef. So I'd actually say this might be a better analogy where there's sort of this separation between here we have the server and here's the API that allows us to communicate with that. So that's actually a better analogy here, slightly different. All right, so now let's talk about REST. So REST stands for Representational State Transfer. But all it really is a architectural style that we use for designing APIs. And so the idea of REST is that it's structured, it makes us structure the API around resources that are identified by URLs. So that's a very important concept in REST. And this will become more clear quite soon when we get to implementation. So let's extend this restaurant analogy and see how we can make the restaurant follow REST principles. So let's say now the restaurant, we've split it up actually into 3 parts. So there is now a bakery, a dessert shop, and of course we still have the main restaurant that handles like the rest of the meals. We still have the same menu as well, but now the menu is going to be split up between these different sections now, which each handle those respective dishes that you might find in the bakery or the dessert shop. And so much like how, right, so in each section, we still have all the dishes we can expect. But one thing that would be, I guess, we think about the developer again, and we sort of come away from the restaurant. Much like how a customer would look for the heading bakery to see the dishes there, a developer would change the URL to send to the API to specify the resource they want. So, and we'll get more into examples of that very soon when we will be going over like an actual worked example, and I'll show exactly how the URL changes depending on what resource we want to get. All right, so now we've talked about REST. So REST is, again, how we design the API. So now let's think about the requests that we can send to the API. And so there are a couple different request types. And so again, the request types we're going to talk about are a very systematic way to interact with resources in a RESTful API. So, this sort of RESTful APIs or APIs that have been built using this REST architecture will have these methods here. And so here is a concise summary of the types of requests that we can expect to want to use with an API that has been built using REST. And so again, one of them is going to be called GET. So it's a GET request. It's a type of request we can send to just to retrieve data from the server. We have POST. So POST is when we want to create a new resource on the server. PUT is for updating an existing resource on the server, so usually replacing it. Patch, on the other hand, is to update an existing resource, but to modify it. So, often there are some differences between these, like this, put and patch seem kind of similar. They're both updating something. Now, there are some more key differences about them that we can get into later. And of course, we also have delete. So delete is for removing a resource from the server. Okay, so these are request types. Now let's think about what sort of responses can we expect from the server? Like, what will we get back depending on the request we give? And so we have 5 categories of responses, and usually there are status codes associated with these. So we're actually going to talk about these status codes, response codes. Because when we send a request, we want to find out what happened to it, right? Was it successful? Was it unsuccessful, right? And also, if it was unsuccessful, like what went wrong? Was it something on our end at the client, or was it something at the server end? So we have 5 categories. So the first one is something we call informational response. So that is for all status codes, and I've sort of put in brackets here. 100 to 199. So I just put 1XX just to symbolize that. And so these are status code. If we get a status code, in that range, these are just preliminary messages. So they're often used to signal that the server is working on the request but hasn't completed, or is giving us just a purely informational response. Now we have 2XX, so 200 to 299, so that corresponds to successful responses. So what that means is that our request was successful, and we usually are getting the expected response if this is the case. Then we have 3XX, so 300 to 399, so these are redirection responses. So what that means is that some further action on our end is needed. Now, often these are used when we want to tell the client to go to a different URL. And then we also have 4XX. So this is for like client error responses. So usually it means that there could be a problem with the request itself and how it's been formatted. There might be certain things that are missing. So this kind of goes into, we mentioned earlier that APIs, if we want to communicate with an API, we need to have a very specific protocol or rules have to be followed in how we send our requests. So we can see that here where, maybe if our request is not formatted right, we might get a client error response. And then we also have 500, so 5XX for server error responses. So it means something has gone wrong on the server side. So, there might be some examples of this that I can already think of, if there are too many people trying to access one server resource, the server might get overloaded with a number of requests, and it will actually give these like error responses. All right, does anyone have any questions so far about anything we just covered? Feel free to type in the chat. Okay. Oh, yeah. Okay, awesome. So what we're going to do next is we're going to look at some examples of this and we're going to think about them. So let's think about some examples, like real world examples of response codes and also these like request types. All right, so what does everybody think about this? So you attempt to retrieve a YouTube video's details using an API request. What category of status code might you receive? So like roughly a range of status codes that we might receive based on what we have just seen with the different categories. I will also write in the chat. I'm actually I'll share this in the chat just in case. All right, so technically the answer is we'd receive 200, but I think some people these are some good answers. I'm seeing like 4xx. That could certainly be the case. Yeah, if the video was deleted, then we would actually get a 4xx because that would be an error on our end where we have sent in like I think each video is identified by URL. And in the URL there's like the ID of that video. And so it could be that if the video is deleted, it's not on their server anymore, then absolutely we'll get a 400 something, it'll be a client error. Definitely we could get a redirection. Yeah, so we'll go into how to get status codes a little bit later. I'll actually show it what it looks like when I show one of the software we use. Definitely, we could get a redirection as well. So I know that sometimes on Zoom, I get if I try to open a meeting, I might get to an intermediate page that is asking me to redirect and like click something else to open the Zoom application. And so that is an example of a redirect. So I can certainly imagine a redirect happening for a YouTube video as well. Like maybe maybe the video exists but something has been changed where the URL is slightly different, but it's still similar enough that YouTube can figure out that, okay, this is the video we want. So it would give us a redirect. It might ask us, are you trying to access this video? And it puts the link there. I could see that happening. All right, so check this out. This is another question. You try to fetch a video using an API, but the video is not found on YouTube. What status code might you receive? Awesome. So let's see here. Okay, yeah. So it is 4xx. Yeah, 404, don't worry. 404 is in that category. Now, I think when we release the lab, I will put a document in there which has like more details on like the difference between 404 and like 400 because there are a lot more codes inside of like that range, but definitely 4xx is correct. Okay. So now let's go to REST methods. So you want to post a comment on a YouTube video. Which REST request method would you use to create and submit your comment? Okay, so I will put so I'll clarify REST request methods. So these are not the 1xx, like these are response category. These are response status codes that we can get, but these are request methods or types. So I'll write a few here. Those are some examples. Maybe let me find some definitions. Okay, so most people are saying post for sure. So post is the correct answer for that. So, and let's actually, we can maybe go back here and let's see. So post create a new resource on the server. So yeah, that is correct. So I see a question here. What is the 2xx, 4xx? So 2xx and 4xx, those are just numbers. Those are like to represent numbers I put just to represent a category of responses. So if we send a request to a server, if it's successful, the request is successful, we will get a status code to represent that as being successful. And that'll be in the range of 200 to 299. And so that's what 2xx means. And 4xx means that if we send a request, but there's an error basically in the request itself, and the status code of the response will tell us that. And it will tell us that by using a status code in this range of 400 to 499. And so that's what 4xx means. Okay. All right, so I think before we go for our worked example, because I think next we're going to go through a worked example. So yeah, let's take a 5-minute break and then let's cover the worked example. For sure. I will actually, let's go back here. So the one about get and post, for sure. All right, I'll leave that up for the next 5 minutes before we get back. Right, so I will have like we will have some summary like videos in when I went in the lab. So there you won't actually need to watch the recording again, but of course I will put it on there. So I noticed a pretty good question here. Can we use get and post in the form for us to send and receive information? Yes, because I remember when we were working with the forms where we had some data, you know, before we got rid of that thing, with a submit, clicking submit with a form and having input fields like filled would actually change our URL. So yes, it can be used to send and receive information if we have everything set up to allow for that. Yeah. But I would say not to worry too much about that. So as far as the project goes, like that's sort of separate. We don't want to introduce this sort of REST to that because the project is just purely front end. There's no back end like server that you're sending requests to or anything like that. Yeah, so we just had a 5 minute break that just ended. So, all right, so let's get back to our lecture. So now we're just on the last bit here. And what we're going to talk about now, we're going to go through an actual example that we have sort of set up. So we might be thinking, okay, so we already covered this and here. Okay, so let's talk about a worked example. So you might be thinking, like, where do we go from here? So, we've learned about APIs for, how we might communicate with a server in a way that we don't really need to know how the server works. And that's great. We learned about the request types that we could send to this API or this server. We can get resources, we can upload resources, we could delete things. So that's great. And then we also learn about status codes, where depending on how our request was processed and whether it worked or not, we will get a response to notify us of that fact. So, what do we do with all of this? How does it sort of fit together? And we're going to go over an example that clearly illustrates that. Now, what we're going to be using is, because there are a lot of moving parts, so I thought that what I'll first actually do is just show what I'm doing just visually, and then I'll go into the code, and actually run through the example using the tools that I'm about to describe using. So I'm going to use a client service called Postman. And I'm going to use this to write my request and send it. So there's two things I need to send this request. I need a request type. So I need to specify, is this a GET request? Is it a PUT request or a POST request? So there's that needs to be specified. And I also need to talk about, I also need to mention, since this is REST, I need to have a URL. What is the address that I'm using? And now we also need to think about, like, where am I sending this request to? So I have set up something called a mock API. So, the mock API is actually going to be separate from the server, but we can think of these as effectively the same. So I guess a good analogy is that if a server is a building, the mock API, we can think of that as windows, or like the different entrances to this building, basically the different doors to try to get to this building. And so I'm going to be sending the request type and the URL. And more specifically, this URL is almost like going to be an address to the API. And this would be a little bit more clear when I actually show what it looks like. So this is actually what the URL is going to look like when I send my request. Now in green, I've specified that this is a GET request. The blue part here is the server address. So, HTTPS, there's a bunch of numbers, .mockapi.io. And the red section is the resource I want to try to access using the API. So the blue and the red portions together are what we call an endpoint. Where in that case, what the endpoint means is just like when there is an action that is linked to that request. So maybe this, yeah. So the API, the endpoint, so both of these, the blue and the red section, is giving us an address to access resources on the server. Now, more specifically, we want to access these tasks. So that's that red bit there. The blue section, the blue part, is just the server address. Okay. Does anyone have any questions about that? Right. So the IO, the blue section totally depends on what the server is. It'll be different for different servers. Like YouTube will have a different name. It'll be probably like YouTube something something. There'll be the link will be the URL, like the blue portion will be different. And even the red portion will be different. And I'll show how that will change depending on what we're trying to do. Just because I'm using mock API to make it, that's just what the mock API server address looks like. And then when I add to that this /tasks, that specifies that it's an endpoint. So we want a specific method done. So the reason I'm not using a post method is because I want to get the tasks. So this endpoint here, /tasks, it's going to be a get request. Because I just want to get my list of tasks. I don't want to post or update the list with another task. Now we'll talk more about what that'll look like when we update it. Yeah, so I think IO is the same, but don't worry too much about what this IO is, because the thing is, it'll be different depending on, the URL will be different depending on what the server is, basically. So let me actually try to find some examples of server URLs we send, which have API endpoints, just to show that it really can change. Here are some different API endpoints. So that blue portion that I showed here, this bit, it really does depend on even the red, because again, the red, I'm trying to access a resource that exists on that server. Now, because I made this, I know that it has the tasks, but it could be different depending on the server. So here I have an example here. The Twitter API, that blue portion would look like this. The GitHub API would look like this. The Google Maps API would look like that. The open weather, okay, so here, can you give me an example of an open weather map endpoint? I'm trying to get weather data for New York City. So we'll see a more in-depth example here. Okay, so check this out. So this would be the blue portion. Sorry, this bit, that would have highlighted in blue is basically kind of like this. It's just a server address where we can send our request to. Whereas this portion here, this has some data about that, okay, I want to find weather data about New York, and then, well, here it's a key. So, these guys, they probably don't want someone always pinging them for information, since that costs money. So they will give you a key that you need to use to get access to their endpoint and sort of get that information. But what I've highlighted here, accessing that resource, is kind of like this red bit. Whoops. At the server, our endpoint, we're trying to access this resource. And here, at this server, we're trying to access, more specifically, this would be I'm imagining, yeah, this is a GET request to the endpoint. So this specifies that what the resource is, that we want information about New York. And we even have to give it some information. We have to give it a key to get that information. Does anyone have any questions about that? Here, I see a question here. The API, kind of like the local path on one's computer, the red part you have. I think that's a good way of thinking about it, but also maybe I would say with that analogy, having that red bit in there is sort of links the address to an action. Because having this here, /tasks, it sort of tells me that, yes, the blue part is the address of the server. And then having the /tasks, now I can access a resource on that server. So there's going to be an interaction. There's a very particular function if we have that with the endpoint. Yeah. It would almost be like, I guess, if you copy and paste a very specific, let's say, address into your file path, and suddenly a Word document opens up. For sure. So actually next lecture, I believe it's next lecture or maybe the lecture after that, we're going to be talking about different requests like post and using these. So this lecture was just to talk about the sort of general idea of, we have this URL, we have a server, and then we can also get specific resources on that server with the endpoint. Yeah. Okay, awesome. So, okay, so let's go back to our slideshow. Okay, so let's actually, oops, before we get to that, let's actually go through this. Exactly. Okay, this is perfect. Yeah, I see here. Do action, exactly. And then the path, yeah. So this is kind of like server address, and then this is what we want, the specific functionality, what we want to do with that server. Like, I guess both of these together is the API, is the endpoint. Exactly. Now this specifies what resource we want to access on that server. So it's going to be tasks, and this is just the URL of that server itself. So let's actually we're going to use Postman to send a request. And so I will mention that Postman is not sort of by default on the machine. Now you can either, and I will put a link here, you can either download Postman or you can just, I do believe you can open on the web browser to use it as well. So this is and I will actually share this in the chat. So that's the API. Now I'm not sure if when I made it, I think to have collaborators be allowed to use to send requests to that address, I have to have like the pro version. So it might not work. So here we're gonna use Postman. So basically what this looks like is it just lets us send requests to endpoints. Okay, well, yeah, I think they're quite particular about not letting, having to upgrade to pro version to get many people to use that. It's interesting how they know who's sending the request, but yeah. So I guess what we could do, let's go into headers. Okay, so this is my request. Yeah, so this is Postman. So I'm on the lab for today. I'll put some links that explain like more about what this is and where to get it from. So this is my address. Now, again, this is the endpoint for tasks. And now I mentioned that we have a type, we have a URL, and we will also have some data that we'll send as well. So the data is represented in this params. Usually it's going to be an object or a set of key value pairs. And I think we can see that here, key value. Now, the way this GET request is set up is that we don't actually need to send anything other than just the information can just be in this tasks or in this URL here. Yeah, so I don't think this works. Now on my end, it works. It might not work on your end, and I think that's because, yeah, it is I am logged into my account, so it could be why that's working. All right, but this is more just for a demonstration of the idea. So let's send that request. Let's see what happens. Okay, awesome. So notice here, status 200 OK. That's the response code. 373 milliseconds. Okay, not too bad. And this is the data I get. So this was a task. Oh, it is working. Okay, awesome. So I guess it does work. So yeah, so when you go to that URL, let's see. Yeah, like when you go to this URL, it's kind of the same as doing this. Because what this is doing, and maybe I can, oops, go back to the normal dimensions. Okay, check this out. Does everyone see that right there? So this Postman is doing the same thing, and I'll actually explain what this is doing. In my web browser, when I go to that address, it's sending a GET request to the same URL, right? And then, so these are what I guess you could call the headers. So it's essentially what we're sending to the server. That's the URL of the endpoint. The method is GET. The response I get is 304, which and normally, I guess that's interesting. It's a redirection, but we do get what we want. So I think that's fine. That's something I can look into. Why is not 304? But it looks like it's okay. And let's actually look at the response here. So there's a lot more detail than we need to worry about. But if I look here in the response, this is the response I get. It's basically the same thing that I see here.
Alim, can you tell me how you can open this particular screen where you are showing a response and preview?
For sure. So I just go into my developer tools. So here, these three buttons, more tools, developer tools. And then here, I make sure I click this network. Now, I need to like reload to re-perform that request. So I'll just hit Control R. And then here, this is the request on the side here. So this is a request for, this is the one for the tasks here. And we can see here the headers. So the header is basically, it's this stuff. So we can send the request using Postman. We can also see that if we go to the URL, the request is also being sent to the server to grab that information. We can see the response here as well. One interesting thing that I think I should mention, see this like favicon.ico? I believe that's this icon you see here on the tab itself. This like, does everyone see this? Like this little icon mock API might be a bit hard to read. So just on the tab itself, if I click that here, this is like, how did I get that response, right? So here, see how this one is /tasks? So at that endpoint, it's a particular resource we're trying to access /tasks. Because we know it's using REST. It's using that REST where it has resources are specified with slashes in the URL. If I click this, notice how I have /favicon.ico. So it's a different request URL. And the response, well, there's no response data. I actually want to see what happens if I try to go to that. What do I get? Oh, nice. So I actually just see the image here. I guess that is how it's getting the image. Okay, awesome.
So
right. So if I see a question here. Sorry, Marwan.
How did you get to developer tools in the inspect? I think that's what a lot of people are trying to figure out because we're trying to follow along with the inspect. But I just don't see the same thing you see. Like I see the inspect, yeah.
Here and then more tools, developer tools.
Oh, okay.
I'll make sure that this is like sort of extended, and I click the network here. And then once you're on network, there's usually nothing here. So I'll just hit Control R to reload. And then tasks here. Now these are both requests that are being sent. And you can actually see the times up here when they're being sent. So if I click tasks, tasks is this stuff here on the left-hand side. And so here we can see headers, preview. This is even like a preview of the data, the response that we get, what it looks like. All right, so is everyone sort of all right so far in terms of getting to this this sort of view? Right, so after clicking network, we want to click Control R, refresh. Then see this tasks here, we click that. Control R. Now what Control R does, thing is if I open this again, to refresh, basically when I'm here, like there's nothing here, I need to refresh it. Sorry, I see a photo here. Yeah, exactly. Hit refresh and then like hitting refresh constantly, you see how it just sends the request again and again. So it's good to mention. Yeah, and I'll just hit tasks and now I can see like the full, I can see the request. So this is the request URL, the method used, the status code, 304 not modified. We can actually look at what that is. What does 304 not modified means? Okay, so it just means that the website we're requesting hasn't been updated since the last time we accessed it. Typically, your browser will save or cache web pages so it doesn't have to repeatedly download this information. Okay. Because it is just a GET request, so there's nothing has been changed so far. Yep, you can use F5 to refresh. As long as it will display that tasks thing, then it is refreshing. So yeah, if that works, I mean that.
What is
But
the colors on the top? I see it's like 100 milliseconds to 200 milliseconds, but is that that's just saying how long it took to reload the page?
exactly, yeah, let's actually look into that. So here, if we go to timing, we can see that, okay, so these are more about how the connection was actually made, like DNS. The initial, so if I remember, DNS is almost like handshaking. So you can imagine the client and the server sort of does this handshake to, it's their first communication to ensure that like they are actually connected. They're making, they're able to make the connection. So the first 104 milliseconds is that, and then 201 milliseconds is initial connection, and then 102 milliseconds. Now there's some overlap here for SSL. And then here, the request to response. So once all of that is done, like the lookup and the initial connection being made between the server and the client, once that's done, then the request is sent. So that was us going to the URL. Like this URL, this was the request that we sent to the server. That was 1.23 milliseconds. 90 milliseconds of waiting for the server to respond to us with the information, and then 1 millisecond roughly to download the information and to display it. So yeah, it is sort of color-coded, these timings.
So
okay,
basically, however like big the file is, or however traffic that URL has, it will show like how quick it was in responding to your request. Like if it's a very busy site, that wouldn't, like this would be, it would take a lot longer, right?
Yeah,
Okay.
absolutely. Yeah, there's a lot of like little different bits here. Cookies. I'm not sure what these are, to be honest. Like I know what cookies are, I just don't know what in this context what these are. But yeah, okay, awesome. So yeah, as you can see, like this is basically the same as this. Now, let's say, what if we want a specific task? So here, each task, so this is just the data here. And notice how, like, this is the same data on the web page. And notice how each task has an ID. So we might be thinking, how can we change the URL to get that ID? And so this is part of REST, but it's also in our docs, in like the docs for using this API endpoint, is that if we put another slash and we put the ID we want, we'll be able to get that one. So I want to get this task 1. I believe this should work. Yeah. So now, again, /tasks gets us to the tasks resource. And inside of that, I want a task with the ID of 1. And this is part of REST, that we can modify the URL to reflect the resource that we want at that endpoint. So if I say /1, that basically means that I want tasks, and now I want the ID, like the task with the ID of 1. And now my response is one of them. And again, it's 200, okay. Everything worked. Now notice how this, if I remember correctly, this is much faster than, because here it took like 400 milliseconds or something to actually display this. At least that's what it said. Whereas here it took about 114 milliseconds. So let's see. Okay, so 1, and getting it from here will be the exact same thing. All right, so I've got the same information. 200, okay. Headers, it's the same URL that I'm sending. This is and this is the response. It was just the same task. All right. Exactly. Okay, I will mention, I think you brought up a great point. We'll talk a little bit about what JSON is. So let's take a look at that. Talk about what JSON means. So not all URLs include ID. We only include the ID if we want that. So there is, I guess, I'll put it here. It's almost like this is our endpoint. Whatever is after this, we have slash, we have our endpoint. Now I've set up an endpoint for tasks. If we want the ID, if we want, so I'll talk about JSON, but I will mention that not all URLs will have the ID. If I want all tasks, I don't need to give the ID. If I want a particular task that exists, like 3, let's say, and I know that 3 exists here, I'll put /3. And now I'll get that specific one. But it doesn't need to be that way. So yeah, let's talk about JSON files. With JSON files. So JSON is basically, it is a format for the data that we can get. Now, the reason why it's giving it to me in that format is because I actually said here, I actually made an extra header here where I told it that I want a JSON file. And so what that means, so what JSON stands for is JavaScript Object Notation. So what that means is that we will essentially have JavaScript Object Notation will use curly braces to represent objects. And then collections of data, so multiple objects, it will use these array brackets. So notice how all of this is enclosed by this sort of array, these square brackets, that, and then this one here. And then also each object is enclosed by a curly brace. So let's actually see what this looks like if I put /1. Put /1. Okay, so again, we'll see it will be enclosed in our bracket there, curly brackets there. I want to actually see what it looks like here as well. Okay, so it looks the same. So this is Postman. I will have some links that talk more about this in more detail. So this is just an application I'm using to send requests to this endpoint. Okay, so let's talk a little bit more about endpoints, and more specifically, I think there are more kinds of endpoints that have been set up. So we will pass that. Okay, so these are other, like this is all for the same resource, but essentially I was just showing that getting all the data was just /tasks. And remember that for, if I wanted a specific one, I would put the ID as well. So I'd put / and then these two dots, what these mean is that this will actually be different. Like it's not, what it means is that you don't actually type in ID, but you put the number, or it could even be a string corresponding to the ID, what the ID is of the task that you want to get. If we make a post request, again, the address is actually the same task, but this would be post. For put, this would be put, and then also we would use these slashes and with the ID here. Yeah, so you don't actually put the colon. So the colon is there just to represent that you don't type in ID, but you put the actual ID of the thing that you want to change or modify. So the ID could be a number, it could be a string, but whatever it is, you actually have to put that ID. So that's why we specify with the colon here before the ID. And I will actually mention that for some of these, like for post, you might be thinking like, how do we send I change ID with another key. So, it's a good question. Yeah, so this PowerPoint, I have uploaded it, and as soon as the lecture is done, I will publish it. So it's a good question here. Can we change the ID with another key? I think if we specify, so the thing is, these are actually built in. Now it might be different, like it might not be the ID. Sometimes it might be a get on the task name. It really does depend on how we've set it up, but it can definitely be a different key. Yeah. It's just that this, and notice also how we don't have to worry about how the server is getting that. Like when I sent that request, all I need to do, for instance, is just put this like in the URL with the ID that I want to search for, like 1, 2, or 3, right? I don't need to worry about how the server gets my URL and how it grabs that task and returns it to me. So put and post, these are different methods. We'll go more into them in future lectures. But right now we just need to worry, like get, we want to retrieve data for this from the server. I put these post and put here in the sense that the URL is very similar. Like notice how get is just tasks and then post is also tasks. Now the only thing that would be different here for post is that this like green bit would be different. It would be post. And then also for post, instead of having, we actually need to provide some data to the request. And in particular, we actually would want to give it the task we want to save to the server. So I will, and that'll be, I think we're going to cover that next lecture, if not the lecture after. So the lecture tomorrow will actually go into more detail about how to send those requests that can actually update these tasks or add more tasks. Put and delete. So they're not, I guess, put, oh, okay, I see, put and delete. Okay, yeah, because both of these have the same address, right? Like task slash and then the ID, and then here it's also ID, right? They are similar in the way that they have, but both have the same address, but they do different things. I will also mention that notice how put we are updating some data on the server. So if I put slash tasks, if I put slash task slash one, and then I would probably need to provide a data object to as part of my request. So I'd have the URL, which would be this like blue bit, and then slash tasks, let's say slash two, and then I'll have a new object, which is like the task I want to replace the task with the ID of two with. Whereas if I sent the same request with a delete, I would not need to put a data object in because all I'm doing is I'm just deleting that task. Whereas the put request is going to find that task using the ID and it's going to replace it. So I hope that clarifies the put versus the delete. So that's a great question. Where do we put the data object? So again, we'll get into this later, but I'm correct. I believe if I change this to post here, let me see here. I believe you would actually put it in the body here. Now I can try this. Example. Okay, so let's try that. So let's just see if it updates the tasks. So let's see again here. So remember here, post is the same address. So I'm going to create this object. This is not a task. It's just going to be some random object. I've just made this object here with one key value pair. So the key is test and the value is example, the string example. And I'm going to put this object in the body. So just to see it here. And I'm going to send it to there. And let's see what happens. Okay, perfect. So notice how the response 201 created. And it created this. So it looks to me like what it's doing is it's probably filling in all this other information. And then it puts this extra bit here. This is just how it internally handles it. It is creating a task. And remember, all the tasks had these fields. And then whatever I put in the body here, it just added that to that object that it made. Yeah, it looks like it created its own ID. So let's see here. Notice how now I have a new task. And I even have the key value pair that I put in, that I sent in as data, is now actually in this. So I actually didn't know that it was going to do that. And that's the thing, like we don't need to, exactly, yeah. So it's just based on the order. Now, this mock API, it again, like, I don't know how it works internally, how it's actually parsing what we send it. So I was curious. I just wanted to test, like, how would it create, how would it handle a post request? Would it just directly put the object in? So would it have just been an object with that one key value pair? Or would it create another task with all the relevant task information? Task 20, created at, important, ID, and then just add that key value pair. So it looks like it did the latter. And that implementation is actually hidden from us when it comes to these APIs. Yeah, we'll get more into you know, one thing I did mention is like we're using Postman here, but you can actually also do this in VS Code. And actually next lecture, the afternoon lecture, that's something we're going to talk about and go into in much more detail, like how to actually code it in VS Code and run that so that you can do it through that. You don't actually need to use Postman, although Postman is a good tool to have. All right, so I guess let's get back to our slideshow here. So yeah, these were just a few more examples of how changing our URL will modify it. Like we change our URL to modify how we want to interact with the server. Do we want to get data from the server? Do we want to get all the data or a specific task? Do we want to add more data, or do we want to put or update or even delete exact or basically delete one of our tasks? So as can be seen, the URL will change accordingly depending on what action we want to perform. And so that is the idea of having like a RESTful API. The action is encoded in the URL itself. And that makes it, that's part of the reason why it's easier for us as developers to use like something like this. Like it is, how would I put it? Based on the URL that we're sending, we know what actions we want to happen. So each API endpoint has its own unique URL, as you can see here. Now, I will mention like get, like these, you won't find the same request type with the, you won't find more than one of the request type with the same URL. Like you wouldn't find another get with the same /tasks and have that be a different endpoint. So each endpoint has its own specific URL that's unique. And again, I mentioned this earlier, but we can think of API endpoints as being linked to a specific service that is provided, like getting tasks, adding tasks, deleting tasks, and so on. So that is actually our lecture. Does anyone have any questions about anything we just covered or clarifications? Yeah, any questions at all? You know, feel free to unmute or type in the chat and we can review that.
Sorry, I have a question, but this is super embarrassing. I missed the first like 15 minutes of class, so I'm not even sure like what the whole purpose of this is. Like I get it, like I understand everything you said, but why do we do
Right,
it?
so the first, I guess I can do a quick recap.
Or you
so
can just go to the first screen and I can just read it.
For sure, yeah. On the lab, I will also put some, we will have some like resources for like quick videos that will recap on some of these concepts. So I see a question here, the JSON file, do we build it or is it automatically done? So when I send the request and it responds with data, I can tell it that I want the data in that particular format. So it's sort of automatic. I don't have to build the file on my own end. Now in the future, we will be building, like we've been talking about APIs and servers and like these endpoints where like we send, as long as we have the address, we can send something to that endpoint and we can get a response in the form of a JSON. So later on in the course, we'll be building these backend servers that receive the information, and then we'll see like how do we internally handle the data once we are at that endpoint. Like from the perspective of the server, how does it handle that? And how does it send a response back to the client? So that's something we'll get into later in the course. And that's actually a place where we would need to build the JSON file. We would need to specify we want the response to be sent as a JSON. Okay, awesome. Yeah, so everything like this, like the REST concept of having the slashes to access specific resources. So like making life easier for the developer. And also for, of course, whoever's developing the server as well. That is, all of that is like a certain design or style for building an API. And the API is what lets, me as a developer, for me to interact with this tasks, like this server that I've made here. The API is what lets me interact with it easily without having to worry about how the server is implemented internally. All I have to do is just send this request basically, and I get the data. It's more, I guess it comes more into play where, let me actually pull up here. So remember we were talking about this like open weather API. So that's a more interesting example of an API, and I will cover that in a future lecture. But it's pretty similar. But here with open weather, we can tell it that like, okay, I'm in New York City. I want this weather, and it will give me the weather. And all I need to know is how to send that request, and that's it. I don't need to worry about how it's like getting the weather or doing any of those calculations. So that's actually like at its like simplest, like that is what the API lets us do. It lets us have that interaction without needing to worry about what's happening server side. So we will create, we will certainly create, we'll build servers and we'll build endpoints that, and of course we will make APIs as well. Like we will build APIs so we can send requests to our own servers. But there are a lot we can use from the web as well. Yeah. So with that, we're going to take a 10-minute break. And then we'll be back for lab. So yeah, let's go on a 10-minute break. So at 9:45, 9:46, we'll be back for our lab.